Welcome to this special episode of Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle, and today I'm talking with CJ Reddy, Vice President of Business Development for Electromagnetics Americas with Altair. Welcome, CJ.
Thank you, Pat. Glad to be here.
So today I thought we would discuss electronic system design, and let's start with what are the challenges that engineers are facing in electronic system design today?
That's a very good question, Pat. I think electronic systems are becoming part of a product, any product you can think of, because most of the products we think of nowadays are becoming smart products. What that means is that the product not only does what it has to do, but also it connects to your phone and to an app and other kind of things. So this could be your mobile devices we are using, but also the smart speakers, smart homes, and Internet of Things, and so on and so forth. So designing of electronic systems for these products is becoming more and more complex because they not only have to work with the device functionality, but also there to be a smart as well as connected functionality. So this starts with good circuit design. That's a basis for any electronic systems, but also power electronics, for example, plays a critical role, and high-speed digital circuits also play a critical role. Then comes the RF circuits, which are completely different from normal electronic circuits. Then, of course, the antennas built into the circuit boards also is a challenge because all of them have to coexist. They should not have any EMI, EMC problems. Sometimes it's also referred to as desense. That is, your own circuit is interfering with your antenna functionality. So those challenges need to be addressed. So this, because of this complexity, it is very difficult to do many iterations of the product, or what we can call is cut and try type of iterations that can be very time consuming and also can cause budget overruns. Solution for this is using a simulation driven design. By that, what we mean is that every aspect of your electronic design can be simulated ahead of time so that you have an accurate solution. So before you actually build the circuit, you can be almost 100% sure that the circuit is going to work. But this requires the tools that are accurate, efficient, but also user-friendly. Otherwise, people won't be able to use those tools. At the same time, some of the tools for electromagnetic simulations, for example, for antenna designs, they have to also to be HPC friendly, that is high performance computing friendly, so you can run them on parallel computers. So this will actually, using this kind of simulation driven design, will reduce the cost of prototyping and also saves the time. And hence, at the end, for companies, makes the time to market much faster than if you're going to, let's say, cut and try iterations.
So can you explain Altair's solution for end-to-end electronic system design?
Certainly. Smart connected, as I already mentioned, smart connected devices are everywhere, the homes and the transportation, and we talk about, smart cars and those kind of things, and also at work. It means that, electronic system design having a greater influence almost every type of product, requiring new simulation tools to help us electronic, electrical, mechanical, thermal, and connectivity goals. So that's a lot of things to cover in terms of simulations wise. One of the good news is we have is Altair simulation-driven design tools enable all of them. For example, you can start with electronics, you can do the electrical, mechanical, thermal, and connectivity simulations with a wide range of tools that we have. So our tools, our Altair product tools, can help streamline the process, eliminate the design iterations, and reduce the time to market. So, as we already discussed in the past, Altair now has an expanded portfolio that can help almost every aspect of the electronic system design. Let's start with, let's say, circuit simulation. Circuit simulation always plays a critical role because that's where you start with the basic design of the circuit. So we have a product called Altair Activate that can do a special version of SPICE based on the open source industry standard, which is SPICE is well known in circuit designs. So with that SPICE model we have, you can access the digital component suppliers components, for example. So you can put them in your circuit design. It's a very intuitive schematic-based design that you can do. And of course, you can do the frequency responses, time periods, and so on and so forth. So you can actually assess the electronic circuit performance. As I mentioned, this is part of our product called Altair Activate, which is also a multidisciplinary system simulation tool. Recently, we also acquired a company that does visualization of your ECAD systems. In any complex system, you have different type of electronics things, and they're all coded in let's say, to be specific, in a SPICE, for example. Someone to read the SPICE code and understand what it's doing could be very, very complex. So this tools that we acquired from the company called Concept Engineering, the company that we acquired, eVision and StarVision, you can throw a SPICE code at it, it will turn into a schematic visualization of the schematic. So you can easily debug the code, or you can find out where the problems are, and so on and so forth. So that's, of course, the first step. The second step also is one of the key things for electronic system designs is the power electronics. Every electronic device you have has got a battery. What that means is that battery has to convert the energy into various, let's say, DC to DC conversion or AC to DC conversion, vice versa. So they require simulation of the power electronics. And earlier this year, we acquired a product called PSIN. Now it's Altair PSIN, that can very efficiently analyze power electronic circuits with respect to optimizing the efficiency of the power conversion. And then they also can do EMI/EMC, because most of the power electronics cause what is called conducted emissions. And PSIN can effectively can predict the conducted emissions from the power electronic circuits. So then comes the PCB development. Once you have the circuit done, both either for the normal electronic circuits or for the power electronics, you need to develop a PCB. And we have a tool called Altair Polex that can take any PCB layout from, let's say, Altium, Cadence, Zuken, pick your own favorite ones. And we can bring that in and could analyze the PCB to make sure that ready for the design for electrical, what we call design for electrical, meaning you can rule check and make sure that the layout is accurate. And the design for assembly, that means you can make sure that it's ready for the assembly of the components. Design for manufacturing, that means it follows all the what I call the stipulations of the manufacturing. On top of it, it can also do a simulation of signal integrity. This is very critical for the what we call the high-speed digital circuits, to make sure that the traces are not coupled to each other tightly, causing the signal degradation. And power integrity, and also electromagnetic interference vulnerability, ESD protection, and also thermal analysis on the board level without relying on rule of thumb. In the past, people used to do the rule of thumb, and this can eliminate those kind of things. So at the end, it improves the performance of not only the PCB layout you have, but also allows you to collaborate with other teams in your company. So that's, of course, the PCB electronic side of it. On the physical side of it, you want to do the simulations, for example, solder fatigue, or the reliability of the components on the board, and what happens if you drop the kind of a drop test kind of thing. We have a product called Altair SimLab that can read in the ECAD files and can do the analysis on the mechanical side of it. Even thermal one, for example, and also the, as I mentioned, solder fatigue, reliability of the board, structural reliability, and those kind of things. One thing before we go to the connectivity is we have a product called Altair Embed that actually can, on a visual level, can create a code that you can embed into your system. For an embedded code, like, for example, a microcontroller, you want to program it, we can actually use Embed to create a code visually by symbols. And then the Embed can generate the code, and that can be embedded into the system. for the sake of control and other kind of things. Last but not least, which is my favorite part, is the wireless connectivity, which is actually my background in electromagnetics. We have a well-known program called Altair, which enables the simulation of any electromagnetic system, especially in the case of a product, for example, antenna design, antenna placement on where you want to place it and its performance. And then going forward, of course, we also have, under the same name of FICO, we also introduced propagation tools. So that can take you from antenna design to antenna placement to placing them in, let's say, in a city environment, rural environment, or in a suburban environment, and then can compute the connectivity calculations, simulations, not only the field levels and the power levels, but also by adding the air interfaces of your protocols, let's say LTE protocol, Wi-Fi protocol. We can compute the data rates, including the MIMO propagation analysis, but also including the MIMO calculations, we can do the data rates, channel capacity, and so on and so forth. So this takes you from component level all the way to system level, communication level, channel characterization, and so on and so forth. And at the same time, it also can simulate wireless coexistence, because you have Wi-Fi, you have Bluetooth, you have LTE, you have 5G. All of them have to coexist. And we can do the co-location or co-site analysis of these wireless protocols. But at the same time, we also have tools for spectrum management, which also becomes very critical when you have many wireless systems existing in the same place.
Yeah, that's a very comprehensive suite of products and tools. And Altair will be attending Electronica. And so how can attendees find out the benefits of Altair simulation solutions there?
Yes, yeah. So, of course, the best thing is to visit our booth at Electronica. It is booth number A3562. And there, we have our experts ready to help on how we can help you with the simulation tools we have from end to end. All of them I talked about, from, let's say, Activate to Polex to E-Vision and Star Vision, and Embed, as well as PSIM, for example, and FICO, WinProp, and RAP, all the tools we have. One thing I would like to mention is that we have a unique licensing system where we don't sell these products separately. We have a unit system where we provide Altair units. With those units, you can access any of the products we have in a particular suite. So you don't need to worry about which product I'm buying and not buying. You will have access to all the products through one unique license that Altair offers. It's a patented licensing system. So I do recommend visiting our booth at Electronica and learn about all the things we do in electronic system design.
Well, thank you so much, CJ, for talking with me today about electronic system design. You can visit Altair's website to find out more information, and please visit their booth at Electronica, booth number A3.562. And we can learn more about their systems, as CJ just said, and we thank everybody for listening today. Join us next time on Frequency Matters.